in this case, we've got a hydrocarbon, and the formula, the empirical formula for it is C₅H₆, right? And we've been told that the molar mass for the molecular, the actual molecule, is 132 grams per mole. And so we've been tasked with trying to figure out, well, what's the molecular formula for this? Okay, so what do we know in general? In general, we know that the empirical formula gives us the simplest, or some would say the smallest, whole number ratio of atoms of each element present in a given compound. And the molecular formula would give us the actual number, right, of each atom of the atoms of each element present in a given compound. Okay, so how are we going to get from our empirical formula and our molar mass of the molecule to the molecular formula? Well, what we could do is try and figure out a way to get a comparison between the molar mass of the empirical formula and the molar mass of the actual molecule. And we've been given the molar mass of the molecule in the question. So what's effectively left for us is to primarily start with figuring out what is the empirical formula's molar mass. And we've got, as we've been told, it's a hydrocarbon. We need to figure out, well, what's the molar mass of carbon? What's the molar mass of the hydrogen? We can get that from the periodic table, although given how common these are, you can probably infer, we probably already know what these are, but nonetheless, let's refer to the periodic table. Hydrogen, carbon. So for carbon and for in both cases, as you can see, what I've done, I've highlighted the relative atomic masses. These are effectively, for the purposes of this is effectively the same as the molar masses. Okay, so MR, right? So which would be the molar mass. The molar mass of carbon, as we got from the relative atomic mass, is 12.0, and the molar mass of hydrogen is 1.0, right? And so, okay, so we can now use that to work out the molar mass of the empirical formula. So what we're going to do, we're going to multiply each of these by the coefficients of each element in the formula, and then we're going to sum what that is for each element effectively. So we'll do carbon first. So carbon, we're going to get 12 times, and then here we've got the coefficient is 5, right? So, and we're going to add that to what we get for hydrogen. So in hydrogen's case, we've got 1.0, right? So we're going to do 1 times, and here the coefficient is 6, okay? And what does that give us? So have a go, see what you get when you work this out, and that is effectively going to give us the molar mass of the empirical formula, right? Okay, so if you had to go and work that out, what you should have found is you got 66, okay? 66, and that's effectively going to what we can say based on that is that the MR of C₅H₆ is equal to 132. Well, no. It's equal to 66. My bad. It's equal to 66, and we now need to compare this to the 132 we've been given in the question. We need to figure out what the multiplier is. You probably might be able to figure it out just based on visual inspection, but I'm going to actually articulate my reasoning in writing, right? So the next step in this case would be to, okay, so let me articulate first the formula that I'm going to be relying on effectively. So the formula I'm going to be relying on is that the multiplier, so part of all of this process right now is going to be figuring out first of all the multiplier. So the multiplier here, is going to be effectively the molar mass of the molecular formula right, divided by the molar mass of the empirical formula. Okay, so that's going to give us the multiplier. In our case, we've got both at the moment. Let me just add my units quickly. So that's going to be 66 grams per mole. Okay, so, and in this case, we've been told that for the molecular formula, the molar mass is 132, right? So we're going to need to do 132 divided by 66. So let's just do that and let's see what we get. So it's going to be which is going to be equal to 1. In this case, it's going to be equal to 132 grams per mole divided by 66. Okay, and that's going to be in the same units. Okay, so if we do that, what do we get? So I would invite you to have a go, if you can, whether it's based on visual inspection or using your calculator, what the outcome of that would be. And what you should find is that you should get 2, right? Yeah. So based on that, we can say, well, the multiplier is effectively 2x, right? So that's the multiplier that links our the molar mass of our molecular formula with the molar mass of our empirical formula. And therefore, when we're now in the process we're about to now engage in, the scaling up process, 2x is effectively the multiplier we rely on to scale up. Okay, and remember, we've got C₅H₆. Okay, I'm just going to quickly rewrite it out down here just for convenience. C₅H₆. So I'm going to go ahead and scale this up using our multiplier. So for carbon, that's effectively going to be 5 multiplied by 2. Okay, our multiplier, and that's going to equal 10, of course. And therefore we can say that for the carbon component of our molecular formula now, we're going to have C10. Okay, now let's do hydrogen. So for hydrogen, a similar process, but in this case we've got a 6 corresponding with the hydrogen, so we're going to do 6 times 2, right? And what's that going to give us? That's going to give us a 12. And for hydrogen, we can say what corresponds is H12. Okay, and therefore when it comes to our molecular formula, when we consolidate this, we're going to have C10H12. Okay, and you can kind of do the maths and compare that with the value that came out before, which was the 32, well, 132 anyway. And but this should effectively, you know, this should correspond with the 132. And so this, in this particular case, this is our molecular formula. Okay,